Hello, my name is John Clark and this is my first Inversity submission. In essence, I've applied natural language processing to analyze text using a technique known as named entity recognition in particular. I've created a simple interface to allow investigators to visualize their research in the form of a network diagram. My working title for this is the Named Entity Recognition Diagramiser, which lends itself quite nicely to the acronym NERD. From background reading and consultation with OSint practitioners, I became aware of a few important things. Open source investigations can be quite a lonely endeavor, so there is need for collaborative tools that allow multiple people to work on an investigation. Secondly, tools to allow investigators to put their attention on the most salient details would be a useful thing. And thirdly, neural network techniques haven't yet been fully exploited for OSint purposes. They could be applied to extract details with a high probability of relevance. Brief lesson on natural language processing. They've become quite capable over the years. Neural network applications, large language models that are based on the transformer architecture. They're big, heavy, and compute intensive. Yet also, NLP can be lightweight. Neural nets adapted for specific uses. It is with this consideration of keeping things lightweight that I've developed my application, which could be run on any typical consumer hardware. So, here we have different input options. We can retrieve a YouTube transcript or scrape text from a news website. We store the documents for future reference, and we use neural networks here to give a summary of the entire text and also highlight the named entities. We can drag and drop these entities to associate them with relevant details to build a diagram. Locations and relevant information is maintained. As we highlight different parts of the text, this updates the pattern matches for future, so over time the relevance of the responses we get should become more accurate. Here we can update the model and the data will persist from one model creation to the next. The next thing I'll show you is the cosine similarity search. So we can search the document base for the closest vector embeddings. So imagining that we're deep into an investigation and I've remembered that he was at a rave at a party on the beach, we can find the closest match to this, and here it is. We can source we can find the source of the information. User feedback. Currently limited to only 2 kinds of data inputs, but I'd like to expand it further to these guys. The diagram builder also could be more flexible and adaptable, so that needs some consideration too. Here are 3 priorities for future development. Most interestingly, with user-curated documents, we could integrate this into a neural network training pipeline, so the effectiveness of the models, of the neural net models, becomes greater over time. Thank you for listening. This is John Clark with NERD.